Example 11. Solve the equation over the interval 0 degrees to 360 degrees and also for all solutions. 2 times the cosine squared of theta minus 2 times the sine squared of theta plus 1 is equal to 0. All right, this is the last equation we're going to do in this section, and you have a lot of tools now to solve trigonometric equations. So when you look at this particular equation, there's a couple of things that might come to your mind because there's alternate ways for working this particular equation, okay? One thing you may want to do here, okay, is make a trigonometric substitution. If you see we've got cosine squared and we've got sine squared, and we know that they're related through the Pythagorean identity sine squared theta plus cosine squared theta is equal to 1. So you could solve for either sine squared or for cosine squared and then make that substitution, and then it will turn your equation into one with a single trigonometric function. It will be quadratic and you can go from there, okay? Another thing you can do is use a double angle formula, okay? If you go up here, okay, remember when we were working example 10, I had written out the 3 double angle formulas for cosine, okay? And this first one has a cosine squared minus a sine squared, okay? And that's exactly what we have here, cosine squared minus sine squared. So you could do that as well, okay? So there's different ways of working it. I'm going to work it with the double angle formula, but you can definitely go back if you want to and try to work it with the other method with the Pythagorean identity, just to make sure you get the same answer, okay? So my point is, now that we've learned all the tools, you may get an equation and you might see more than one way to work it, and that's okay. All right, so here we go. I'm going to try, like I said, the double angle approach on it, okay? I am going to use this first identity that I have written up here, which is the cosine of 2a is equal to cosine squared a minus sine squared of a. Okay, so I'm going to jot that down right here. Cosine squared of a minus sine squared of a, that is equal to the cosine of 2 times a. All right, so when you look at this equation, we don't have exactly cosine squared theta minus sine squared theta. There's a 2 in front, but the 2 is part of both terms. So what we can do is first factor out a 2. Okay, so if we factor out the 2 here, we're going to get cosine squared theta minus sine squared theta. Okay, and then we're going to leave the plus 1 where it is. Okay, and then now what's in parentheses, okay, is going to match this quantity. Okay, so this is going to turn into the cosine of 2 times theta. Okay, so this is going to be 2. This 2 stays here. This green 2 is this green 2. What's in parentheses, cosine squared theta minus sine squared theta, that's going to turn into the cosine of 2 theta. Okay, we still have the plus 1 equal to 0. Okay, so what we have so far, we've converted the original equation to 2 times the cosine of 2 theta plus 1 is equal to 0. Okay, all right, so we are trying to solve for theta. What values of theta make the original equation a true statement? All right, so what I'm going to do here, this is actually a linear equation. Okay, here is the trig term. It is raised to the first power. Even though there's a double angle, the cosine is raised to the first power. So I'm going to isolate the cosine of 2 theta. So I'm going to move the 1 over, and then I'm going to divide by the 2 out front, this 2 that I have underlined in red. Okay, so I am, let's see, I forgot to bring it down. Okay, so I've got this 2 underlined in red. Okay, we have to divide it off, and then that will isolate the cosine of 2 times theta. Okay, so divide both sides by 2. When you divide both sides by 2, it's only this 2 canceling with this 2. The 2 inside the argument stays put. You can't touch anything that's inside of an argument. Okay, so the cosine of 2 times theta is equal to negative 1/2. Okay, so this is where this is where we have gotten to. Let me write this again because it looks a little funky. Okay, again, we're after theta. Where do we go from here? Okay, well, you know, we've got cosine of 2 theta. Do we go and replace it with something else that's up here? Okay, well, I guess we could, okay, but I am at this point, I'm going to make a u substitution. Okay, so I'm going to let u equal 2 theta because I've got an argument that is not exactly theta. Okay, it's 2 times theta. So then that's going to turn the equation into the cosine of u is equal to negative 1/2. Okay, so I need to go to my unit circle and find an angle that has a cosine of negative 1/2. Okay, so when you go to your unit circle, we are going to look for an angle whose cosine is negative 1/2. Okay, so let me double check that I wrote that correctly. And yes. All right, so here we go. Cosine is affiliated with the x-coordinate. We know that cosine is negative in quadrants 2 and 3. So that's where we need to be looking. Okay, which angles have an x-coordinate of negative 1/2? Well, that's going to be right here, 2 pi over 3. Or are we doing, I forgot, are we doing degrees or radians here? Let's see, we are doing degrees. Okay, so let me go back and grab the degree measure. So we're going to go with 120 degrees. And then if we look in the third quadrant, this angle, 240, also has an x-coordinate of negative 1/2. Okay, so we can go ahead and say that u, not theta, is equal to 120 degrees and 240 degrees. Okay, so if we go back to our work, we can write this down. Okay, this is u is equal to 120 degrees and 240 degrees. We are not done. You do not go and run and put this in the box. Okay, we are solving for theta, 120 degrees and 240 degrees. They are the values of u, not theta. All right, so let's see where we go from here. Okay, so I'm going to get rid of this. Okay, and now that I have the values of u that work, I'm going to start writing out the general statement. Because remember, I've got to convert back to theta. Okay, the answer cannot be u. Okay, so before you can convert back, you have to write the general statement. Otherwise, it will not come out correctly. Okay, so first thing I'm going to write, I'm going to take the first solution, which is 120 degrees. Okay, I am going to add integer multiples of the period. This is, we're working with cosine. We've also been working with sine. The period is going to be 2 pi or 360 degrees here. Okay, so we need to do that. And remember, this is going to be equal to u. Okay, this is what u equals. Okay, and then I'll go ahead and make a second statement over here. U can also be 240 degrees plus n times 360. Okay, now we need to go back and replace u. U is the same thing as 2 times theta. Okay, so we're going to get 2 times theta is equal to 120 degrees plus n times 360 degrees. Okay, and then 2 times theta is equal to 240 degrees plus n times 360 degrees. Okay, the equation's been turned back into theta. Now we can solve for it. Both equations have 2 times theta. We just want theta. So we're going to have to divide everything by 2. Okay, divide both sides of the equation by 2, but everything is going to get divided by 2. Okay, so we're going to get for this first equation that theta is equal to 60 degrees plus 360 degrees divided by 2 is 180, so n times 180 degrees. Okay, and then for the other equation, we're going to get theta is equal to 120 degrees plus n times 180 degrees. Okay, so these two statements that just came out are our general statements. This is how you're going to generate all solutions. Okay, so we can go ahead and transfer these guys to the last box here. The first equation is theta is equal to 60 degrees plus n times 180 degrees. And then the second statement is going to be that theta can be 120 degrees plus n times 180 degrees. Okay. Now we need the solutions between 0 degrees and 360 degrees. Okay. Remember, 120 and 240 are U solutions. Okay, so if you want theta solutions, you have to generate them from these two equations. Okay, so if I look at the first equation and I plug in n equals 0, I'm going to get 60 degrees plus 0 times 180 degrees. That's going to be 60 degrees. Okay, so 60 degrees is going to be one of the solutions. Okay, if I bump up n to 1, okay, that's going to be 60 plus 1 times 180. Okay, what is that going to give me? Okay, well, 60 plus 180 is going to give me 240. Okay, that's between 0 and 360, so we can write it down. Okay, this is going to be a solution. Okay, if we bump it up again, this is going to give us 60 plus 2 times 180. We are going to be over 360 degrees. Okay, so this is a solution, whatever it is, but it's not between 0 degrees and 360 degrees. Okay, we can do the same thing with the other equation. So if n equals 0, we plug into, well, actually, never mind, I was thinking the wrong thing. Okay, so let's go to the other equation and plug in n values. Okay, so we'll get, if n equals 0, we'll get 120 degrees plus 0 times 180 degrees. That's going to give us 120 degrees, which is between 0 and 360. So that is a solution. And then we'll bump it up to 1, and we'll get 120 degrees plus 1 times 180. Okay, that's going to be 120 plus 180. That's going to be 300 degrees. And so that will be another solution. And then if we bump it up to n equals 2, we'd be adding 360. And so that's going to be bigger than 360. So we're good. Okay. There are 4 different solutions to our original equation in between 0 degrees and 360 degrees. So here they are, 60 degrees, 240 degrees, 120 degrees, and 300 degrees. And using these 2 black general statements for all the solutions, just pick an integer, any integer, pop it in, and you will get a solution to the original equation.